A parent function is the simplest form of a function, and what we're going to do is we're going to be able to take parent functions and move them and transform them in different ways. So the main thing first is just to make sure that we know what our basic functions are. So you have a linear function, which is y equals x, and that would be the line that has a slope of 1 and goes through 0, 0. And that's your main function for a linear. A quadratic is going to have a vertex of 0, 0, and it looks like a parabola. Okay, so that's without moving anywhere. That's just your base function. A square root function, okay, is going to start at 0, 0, and it's going to go like that, like a hook. And that is y equals square root of x as your base function. Okay, you have a cube root function, which would be y equals the cube root of x. And that, again, is going to go through 0, 0. And that's going to kind of be like a, like a snake. Okay, then the absolute value, I'm going to skip over here. Absolute value, which is y equals absolute value of x. Again, 0, 0, it's going to go through. And that's like the v. Okay, and then the other type is the rational. So if we have a rational, the parent function of that is just y equals 1 over x. And that would be, so you have an asymptote going this way and this way. And that kind of looks like this and this. So these are all parent functions. These are all the base functions. So we don't necessarily have to worry about the shape of the graph, but just know that y equals x is a parent. Y equals x squared is a parent. Y equals the square root of x is a parent. Cube root, same thing. They're all going through 0. That's the thing they have in common. Okay, except for the rational, but that's because it's an asymptote. So each of these parent functions are going to be transformed different ways. Okay, so one transformation is a translation. So that's moving the graph either up or down or left or right. Okay, so if there's a plus or a minus outside of like parentheses or outside of your original parent function, that's going to move it up and down. Horizontal, if you have a plus or minus within the parent function, like if it's in the parentheses, it's included with like the square or the square root or something, that's going to move it left and right. And if you remember from before, we talked about this a while ago, that horizontal translations are like the opposite of what you think. So if you think that it's going to go to the right because it's a plus, it's really going to the left. So a negative on the inside means it's going to the right. A positive on the inside is going to the left. Okay, a positive on the outside is up. A negative on the outside is down. So vertical does exactly what you think. Horizontal does opposite. So if we look at these functions, okay, you have the square root of x minus 2. So the parent function is the square root of x, and this minus 2 is outside. So this is going to move it down 2. The next function, the parent function, would be 1 over x. So this minus 2 is technically like on the inside, so that would be a horizontal. And since it's minus, it's really going to go to the right. So this is going to go right 2. And this 5 is on the outside, so that's going to go up 5. Okay, and then x minus 3 cubed. So that's really a cubic function. So again, the original parent function would be x cubed. This is on the inside, so that minus 3 is going to make it go to the right 3. Vertical stretches and compressions are represented by having a number in front of the function. So it depends if your number is a whole number, which is greater than 1, or if it's a fraction between 0 and 1. So if the number is greater than 1, it's going to be a vertical stretch by that number. If it's a fraction, it's going to be a vertical compression by that number. Reflections are when you have negatives involved. So if there's a negative in front, you have a reflection over the x-axis. If there's a negative inside your function, then that's a reflection over the y-axis. So if we look at this first one, the parent function is the absolute value of x, and now we have a negative in front. So since that's in front, this is representing a reflection over the x-axis. Reflection over x-axis. And then this plus 6, that's still going to be a translation. So that's on the outside, so that's going to move it up 6. Now if we look at the next one, 2x minus 1, so we know our parent function is x, but we're trying to just make a transformation from 2x minus 1 to 2 times negative x plus 3. So since the negative is on the inside here, it's in the parentheses, this is going to be a reflection over the y-axis. And even though we have a plus 3, technically, right, it would move up 3 from the y equals x function, but we're translating it from the 2x minus 1 function, so it's actually going to move up 4 because it's going from negative 1 to positive 3. So that's an increase of 4. And if we look at number 3, we want to write one. So write the new function if the graph of f of x equals x squared, so that's the parent. It's reflected, so I'm going to make g of x as my new function. It's reflected across the y-axis. So if it's reflected across the y, the negative has to be on the inside. And it's translated 3 units down. So on the inside, I have a negative x squared, and then a minus 3 since it's going down 3. These are just what the vertical stretches and compressions look like. So if a vertical stretch is when a is greater than 1, so basically you're stretching your whole function, so it's getting like a little bit skinnier. When you have a compression, it's smushing it down, so your graph's getting a little bit wider. Okay, so we're not going to graph these, but just so you're aware of what it's doing. So here, we want to see the transformation from f to g. So everything's the same except for in the g of x, you have a 3 in front. Since that number is in front, it's going to be a vertical either stretch or compression. Since 3 is greater than 1, this is a vertical stretch. And it's a vertical stretch by 3. Okay, 3 is the factor it's stretched by because that's the number. Then the next one, the only thing that's different is this 1/3. So that's a fraction, so that's going to be a vertical compression. And it's a vertical compression by 1/3 because that's the number. So now we want to write a new function. So the parent function is x squared, and we want to vertically stretch it by a factor of 2, and then we want to translate it 1 unit to the right. So let's say g of x equals, so since it's vertically stretched by 2, 2 is going to be in the front, and it's translated 1 unit to the right, so that means that that's going to be in the parentheses. So since it's right, it's a negative 1, and then squared. So there's our function. Okay, then there's a horizontal dilation, which is a stretch and a compression horizontally. So your graph is getting wider, like an accordion. It's kind of stretching. It's going to get wider or get shrunken in. And just like the horizontal translations, it's the opposite of what you think. So if, in this case, the number, instead of being on the outside of the function, is on the inside. So if the number is greater than 1, usually greater than 1 means a stretch on the outside, but on the inside it's a compression. And it's going to be by a fraction instead of by a whole number. Same thing goes for when you're given a fraction. If you're doing a compression, you're going to have a larger number. If it's a stretch, it's going to be a fraction. So it's like the opposite of the other one. So if you remember vertical, you just have to flip everything for it to be horizontal. So if you look at this one, the transformation, what's happening here, the only difference is that 3. So since there's a 3 on the inside, this is going to be a horizontal instead of a vertical, because it's on the inside. And normally a 3 would be a stretch if it's vertical. So since it's a horizontal, it's the opposite. It's a compression. And again, if it was a vertical stretch, it would be by 3. So it's the opposite, which is 1/3. So it's a vertical compression by 1/3. So it's just like the complete opposite. Okay, next one, we have a 1/4. So that's on the inside, so it's going to be horizontal. And because it's a fraction, normally a vertical one would be a compression. So this one's going to be a stretch. And it's by 4 instead of 1/4. Okay, so for this one, we want to write the function. So we have a parent function that is absolute value of x. So it's horizontally compressed by a factor of 1/3. So that means on the inside, I'm going to have a 3. And it's reflected across the x-axis. So that means I have a negative in front. So I'm going to have a negative, I'm going to have a 3x, and then it's down 3 units, so a negative 3 on the outside. Okay, so combining transformations, going from one parent to the transformation, we're just going to write what it's doing. So f of x equals x squared is the parent. So the g of x function, how is this moving? So you have a plus 2 on the inside. So that means it's getting translated to the left 2 units. And the negative 1 is on the outside. So it's going down 1 unit. So it's translated to the left 2 units and down 1 unit. And number 2, you have a negative on the outside. So it's going to be reflected over the x-axis because the negative is on the outside. Then you have a 4. So the 4 is on the outside. So that means you have a vertical stretch by 4. And then you have the plus 3 on the outside. So this is getting translated up 3 units. Okay, number 3. You have a 3 on the outside. So this is going to be a vertical stretch. So it's vertically stretched by 3. And then you have a minus 1 on the inside. So it's translated to the right 1 unit. Okay, and this last one, we have a 1/2 in front. So that's vertical because it's in front. So it's vertically, and this one's a compression. So it's vertically compressed by 1/2. And then the minus 2 is on the outside. So it's translated, and it's going down 2 units.